right, good morning, everyone. This is Ryan Miller with North Carolina Building Performance Association, welcoming you to today's webinar. We are here as a redo of the UNC Clean Tech Summit, which, as some folks know, was unfortunately changed up a little bit earlier this year with some snow. And so we've been invited back to offer this webinar today, and we are very happy to have everyone with us. I'll be serving as today's moderator and do some introduction and a little bit of kickoff. And then I will be very happy to turn the reins over to our wonderful presenters that we have for you all for today. So we'll get started. First off, just thanks to UNC and the folks from the Clean Tech Summit, Greg, Kirsten, and Julia for helping us to get this organized. We are very excited to have more than 100 people on the line with us today. Zero net energy buildings is an important topic to our association at NCBPA and to folks all over the state. So we are very, very happy to be talking about this today and look forward to a great webinar. Just a couple of housekeeping items before we sort of get started with the content. We will be recording this, and so if you do miss any information or if you're taking notes and miss something, then we will be making sure that the video comes out soon after on email, so look for that. We'll also be keeping folks on mute for the duration of today's webinar, and please do use the Q&A feature though. So in Zoom on your screen, you should see a Q&A option. Use that. We will be taking and answering questions there. So please use that throughout the webinar, and we'll be checking that as we go along. Without any further ado, I think then we'll jump in and go forward with today's webinar. So as far as today's speakers, my name is Ryan Miller. I'm the founder and chief executive officer of North Carolina Building Performance Association. I will be kicking things off for us today and offering a little bit of intro. After me, we'll have Barry Buckman. He is with SFLA Architects, and we'll be talking about integrated design and much more features. Rainer Smith is with us. He is the VP and chief operating officer of Building Clarity, and he'll be talking about artificial intelligence, building automation and systems, and much, much more. And we also have Mark Johnson, who is the sales leader for Train Technologies at CalMac Manufacturing. He'll be covering battery, thermal storage, and other forms of technology on the renewable and energy efficiency space with buildings. So first off, just a quick mention of a very pretty European building, and we know that those folks inspire us on passive design and net zero energy and low energy usage and things like that. So this quote just kind of, summarizes where we wanted to start. Energy positive buildings are buildings of the future. The mantra of the design industry should not be form follows function, but form follows environment. This means that the design thinking of today should focus on environmental considerations and reducing our footprint first, and have the design follow this premise. It's a good quote. It talks a lot about the design process, and we'll be talking actually a lot about the installation, monitoring, and systems processes today. This one also mentions energy positive buildings, and we'll talk about that in just a minute as far as zero net energy or net energy zero, or whichever term you want to use, versus energy positive. But no matter what, we at NCBPA and folks on the call with our webinar today are big fans of energy efficiency first, and making sure that our buildings are designed to be low energy users and then powered with renewables to get them to that net zero energy or net positive energy standpoint. So as far as today's agenda, we'll start with some introductions, just a very brief, and then I'll allow folks to introduce them during their segments here. I'll cover a lay of the land in North Carolina as far as net zero energy goes. And then we're going to move into how to do zero net energy. Barry will talk about integrated design. Mark will talk about thermal batteries and much more. And then Rainer's going to focus on some of the operational and system standpoint. Throughout the webinar, we'll cover economics and financing as well. Those are big indicators and points of view to consider in a net zero energy project. And then we've got time for Q&A as well. So as I mentioned at the top, we'll be taking Q&A through the Zoom feature, so please do use that. And then as we get towards the end, we'll be able to open this up and see if there's any additional questions. We've got a few slides towards the end on resources and wrap up. There's tons of information out there about zero net energy buildings, and we'll be happy to provide more of that information as we go along. Okay, so as a brief introduction to myself, as I said, Ryan Miller, founder and CEO of NCBPA. We are the not-for-profit trade association for building performance companies and professionals. We've been around for over 6 years in North Carolina now and lead the way on green building, energy efficient, and high performance construction. We do advocacy work, policy work, workforce development, education, and much, much more. Some of the things that we've been known for in the past couple of years was issuing a report on the energy efficiency potential of North Carolina. We essentially found a 17% energy savings opportunity, mostly through the building sector, almost entirely through the building sector, actually. That information is available on our website, and Z&E is a big part of that. And then most recently, career opportunities in building performance. So if what we're talking about is interesting to you today, and maybe you're a student, faculty member, parent, or if you're an industry professional looking to get involved in the building performance industry, we are the organization for you. So please go to our website, look on the resources tab, you'll find much more information there. And also for any faculty or students joining us today, we have a free membership with NCBPA available to you. During the pandemic and before and after, workforce development is critically important to us. We are available to help students and other folks learn about our industry and find jobs and careers. So please do visit our website, simple email form to sign up on, and you'll get information from us and be able to participate in our association's work. So just a brief introduction of the folks here, and then we will turn it over to them as we get started on their individual presentations. But Barry Buckman is a principal of SFLA Architects based in Raleigh. They do quite an awful lot of work on zero net energy and energy positive schools and other buildings. And so we're happy to have Barry with us today. Mark Johnson is the sales leader for Southern US and Latin America for CalMac, which is a group within the Ingersoll Rand and now Trane Technologies brand. So Mark is joining us from his home in Florida, and we'll be talking about thermal batteries and storage. And Rainer Smith is on the road today and will be joining us on behalf of Building Clarity. Rainer is the vice president and COO and is actively involved in many industry organizations in North Carolina involving buildings and standards, and they are big believers in zero net energy and how to get there. So we're happy to have these three gentlemen with us today. So before I kick it over to our esteemed panelists here, I will offer a very brief lay of the land as far as where zero net energy buildings are in North Carolina and where we think that it's heading. First off, just a couple of those interesting news articles over the last year or so. Zero net energy buildings have been getting quite a bit of attention for a lot of different reasons, whether they're environmental, carbon, or otherwise. Forbes is one of the articles and institutions out there that has recognized that pathways to net zero carbon buildings are in reach around the world today. That is a good theme for today. Net zero energy is certainly within reach. It's happening. We are going past that with energy positive buildings. So we are not talking about something mythical or magical here. This is practical and happening right now. Green buildings also lease up faster, but they don't get the value premium they deserve. This is why economics and financing is mentioned in our agenda, because the economics and financial standpoint of how to do a net zero energy home or building, in our case today, is challenging in some cases. There are added upfront costs that can be offset, and the long-term value is certainly much, much greater for zero net energy buildings than standard buildings. And then also, can we heat buildings without burning fossil fuels? Yes, that is completely possible today, really no matter what size of the building we're talking about. The processing might be a little different on the industrial side, but as far as heating and cooling buildings goes, we can do that with renewables and high efficiency alone. So again, the technology, the way to deliver these types of buildings, it's happening, it's here. We want to see it happen more, and we are able to do that in North Carolina. So as far as definitions for zero net energy, which is the term I'll be using today, but that might flex a little bit with our presenters. Zero Net Energy Ready is one program from the Department of Energy, where a highly energy efficient home or building can be certified to be ZNE ready. In order to do that, it has to be super energy efficient, and then we'll need solar, PV, or other renewable energy systems in order to get to zero net energy, where the energy being used is essentially offset by the energy it is producing. It is therefore net zero. This program is a great target for energy efficiency certification programs. Zero net energy is basically where the energy used is equal to the energy produced, and as I said before, requires solar, PV, or renewable energy systems. Electric vehicles and storage reduce and help manage that load. They are often times a part of those homes or buildings. And the net energy positive is where there is more energy produced than what's used. It does require more solar PV and other renewable energy systems, and integrated design and strong EE practices that we'll talk about today are certainly included. Just to touch on this very briefly, there are other definitions for Z and E where you can consider building scale, community solar, district or grid connected microgrids, for example, and then also utility scale. So just to mention there, we'll be talking mostly about Z and E buildings today. As far as Z and E buildings by the country and then also in North Carolina, the last reported list that we saw from about 2018 from the New Buildings Institute showed 8 Z&E buildings in North Carolina, 7 in South Carolina. We think that that's increased a little bit, but there are definitely not a lot of these projects yet. We are interested in moving in that direction, of course. And then just one last mention on policies and codes in North Carolina. We do have a new clean energy plan that was launched in October of last year. It does not, unfortunately, mention zero net energy, and there's only one code mention, which is one way to set those minimum requirements to get us on the pathway. There are also no state incentives in North Carolina. So we are doing these projects in the state, but we don't really have the policies at the state level that are actively supporting them right now. Large and mid-sized cities and counties in North Carolina are definitely setting 100% renewable energy and carbon reduction goals, but most of those focus on renewable energy. Many don't actually focus on energy efficient buildings. So it's kind of like saying, we want to see 100% renewables and carbon. However you get there or whatever it takes, we think it's going to be a lot of renewable energy. If we had more energy efficient buildings in the first place, we wouldn't need as much solar and we'd meet our goals faster. And then also local governments cannot really set more stringent codes. They can only incentivize them. We are looking to target states like California, of course, which has a state mandate for Z&E homes and buildings by this year. 100% renewable and 0% carbon goals need to have an energy efficient buildings focus. That's why we're talking about it today. And local ordinances and incentives can help, but they will not get there alone. And then just one last mention from me, today's approach to Z&E, this is kind of how we'll be talking about it today. Integrated design from the very beginning. We want to make sure that projects are planned to be Z&E. As I like to say, you don't just happen into a zero net energy project. It has to be very intentional. Lining things up and making sure that that everything's in place for financing, project delivery, control measures, and meeting customer expectations is critically important. We'll be talking about that today as well. And then operations and optimization from the beginning, having a plan in place to make sure that the building is operated, optimized, and continually commissioned after completion so that it stays zero net energy in the practice. And with that being said, I'm going to be happy to turn it over to Barry Buckman to offer the technical details on the design side. Barry, please take it from here.
Thank you, Ryan, and thank you everyone for participating with us today. I know these are extenuating circumstances, and it's great that everyone's able to still connect this way and have a conversation about how do we get to net zero energy. I'm a principal at SFLA, as Ryan has mentioned, and we're a traditional architectural practice, but we also have a studio that really focuses on high performance buildings, and we really achieve that through concentrating on alternative delivery methods. We also have a sister company called First Floor, which is a development company, and that has been really instrumental in how we are able to arrive at some of these projects that I'll be showing you. Right, if you could flip the screen. What I'm going to do today is really talk about 3 overarching kind of process level discussions, and I'm coming at it from the idea or from the standpoint of the architect. So how do we get there from a design standpoint, from a kind of leadership standpoint, And then interspersed in this conversation, I'm just going to show you a couple of the projects that we have done in North Carolina that have actually gotten to net zero. In this case, we strive for energy positive. This first project completed back in 2013 in Hope County, North Carolina, Sandy Grove Middle School. It is the first energy positive school in North Carolina. And what's interesting here and why that was achievable was that we acted as the developer and owner of this building. So we actually owned it, leased it to the public school district. And it was through that vehicle that we were able to bring creative financing and different strategies to play that allowed us to get to net positive energy. Sandy Grove today is actually producing about 40% more energy than it uses on site through solar panels. Next screen, please. So the first big concept I want to talk to you about, and again, there's three that I'll go through, but the first one here is integrated design. An integrated design, just from a definition standpoint, it's really a method of achieving a net zero through a collective process that focuses not only on the design, but the construction, operation, and occupancy of the building over its complete life cycle. Next screen. Why this is important is it really is the only vehicle that we've been successful at bringing all of the players to the table as early as possible in the process. And let me explain that a little bit. In a traditional delivery project, we would normally do from a design standpoint, we would go through a very linear, that's just kind of schematic design development, and it's straightforward. And we have some key players there. Traditionally, the consultants that are hired under the architect are at the table. So you would have your major building system folks there. But what's really missing in that equation is being able to bring on the construction trades earlier, and then even getting into some aspects of who's going to operate the building, how is it going to be operated, and actually getting to be involved in some of the occupants of the building. So when you switch the model to integrated delivery, what you're really saying is, let's get those folks to the table early so that we can use their expertise, we can question different assumptions and really arrive at a different product. And you're doing that really earlier in the project. So under integrated design, a lot of this conversation is taking place during the design of the building. So a lot of the effort becomes front loaded on the project. I look at it as more of an exploratory way of doing the building because you're able to follow different pathways, able to challenge different assumptions. So for instance, if I want to look at a different mechanical system or I want to look at a different lighting system, I can look at it not only from the standpoint of what the rep is able to tell me from a initial cost standpoint or a performance standpoint, I can also look at that in what it might mean as a build maintenance, replacement, how those things play into it. And then also, how does it fit into the goal, the occupant of the building? So it's a lot more holistic way of looking at the problem and trying to tackle and figure out more creative solutions. And in that way, that's why it's kind of essential to the buildings that are trying to get to net zero, because it's not a formula that's easier to follow. You really have to look at all the different components that go into the building and how do they work together and how are they going to be able to achieve your goals. And all of that has cost input. So you have to have people that are there from the trades to be able to give you that real-time information to be able to make those decisions. That also flows into kind of how the project is delivered. In a traditional sense, we always use a design, bid, build methodology. And that's problematic because you don't have those folks identified in the front end. The better delivery for net zero energy buildings is probably looking at either a qualifications-based contract where I can select people based on qualifications, put them under contract and have them there at the beginning. Or you might do something like a design build or a CMR, construction manager at risk type contract. Next slide, please. This next project I'll show you is Horry County. This was completed in 2015-16 timeframe. These are 5 schools that were all built at the time in Myrtle Beach area. They are all working their way towards net positive. And I say that because it does take some some time after a building is completed to get it to its most efficient performance. And so I believe 2 of them right now are performing at energy positive. The other 3 are quickly getting there. Next slide, please. Next concept I wanted to really talk to you about is life cycle costing. Again, this is a method for assessing total cost of facility ownership, taking into account the cost to actually initially purchase something, then to own it, operate it, and then maybe even in some cases the disposal of that building or of that building system. Next slide. Why is this important? Again, it's another way of monetizing what it's going to cost long-term for any kind of component or system or part of the building that we're going to be considering. An easy example here would be LED lighting. When we were doing Sandy Grove back in 2013, LED lighting was just starting to come into play. And so we were able to do a life cycle analysis of that and say, yes, it may cost a little bit initially more than at that time fluorescent lighting, but the payback over time from the energy savings was what made that possible. Another good example would be dynamic glass. One of the projects we're working on now is looking at the idea of tinting, electronically tinting glazing. Again, it's a heavier first cost, but when you start to look at it in terms of what it might do for you down the road, then that decision can change. In this case, for dynamic glass, it's a little different. It may not be necessarily a financial payback from energy savings, although it does have that component. It may be actually coming from human performance or the occupants of the building. Can having a system like that on a building actually improve the performance of the folks that are in there? There's been some studies done that have suggested that is definitely a possibility. The other is just from a marketing standpoint of a project. Does that increase your marketing potential? Does that in turn bump your rental rates? Or are there other ways that you can monetarily suggest that is a good decision to make moving forward in your project? The next slide. This is Jones County. This is the newest one that we've just completed. Again, this project actually generates about 50% more energy than it uses. This is a K through 12 grade school in Jones County, North Carolina. It's our latest energy positive school. So you can see the evolution of our thoughts here, not only from a performance standpoint, but also from an aesthetic standpoint. And obviously we believe very strongly as architects that the aesthetics of the building need to be as valuable as the performance. And when you put the whole thing together, you really do get some striking examples. And I think this building is really a great example of that. Next slide. This is the last concept I want to cover. And I know Rainer will probably talk in a lot more detail about this, but just kind of to set the table for him. As buildings get smarter and smarter and the building systems get more and more complex, controls of the systems gets more and complex, optimization really becomes a true focus. We learned this back when we started Sandy Grove. Again, since we owned that building and leased it to the school district, it was really the first time as architects we were involved in a project after completion. And so since we owned that and had a maintenance contract for the first 5 years, it was really eye-opening to us to see how much or how in depth the process needs to be to really get to optimal performance. Normally, again, under traditional delivery, the contractor and their subs might be involved in a project up to a year later, in some cases maybe 2 years later, and at best what you're getting is kind of a test and balance, and then on some projects you get into some commissioning and commissioning. But even all of those processes, while they're good, they fall well short of really what it takes to make the building perform at peak performance. And we've learned it takes up to 3 years to really get to that point. Next slide, please. And why is that important? I think that's kind of almost self-evident. A truly efficient, high performance building, when it's operating at its peak, really does improve the energy performance of the project, but it also improves the occupant comfort in the project. It also makes sure that all of that investment in equipment is being looked at and it's running the way it was meant to run, and you're not creating some internal conflicts or things that really start to drive down that performance. So you're getting the most out of the money that you've put into that project up to that date. Next slide. And kind of in closing, the last piece I wanted to touch was we've recently taken some of the same ideas that we've learned in the school world, and we're trying to apply them into the commercial market space. So this is a project in downtown Raleigh that we're optimistic hope will get going here shortly. But this is a mixed-use office building that again will be producing more energy than it uses. You can see in this application, since it's more of an urban setting, the roof in and of itself isn't quite enough for the solar panels that are needed. So the becomes much more of an aesthetic and actually cantilevers out past the footprint of the building itself. So this is very exciting. We're looking forward to getting this one going and are very optimistic. And I think that's really all I have to say for today. I hope we do have a lot of good questions and answers or questions. Love to dive into some of these concepts in a little bit more detail. I'll turn to Ryan.
Okay, thank you so much, Barry. This is a great project that we're also optimistic on to leave on. We're excited for this one and know that this would be pretty much the most high performance energy efficient building in the entire country. So we look forward to hoping to see that one here in 2022. Thank you so much for the information. At this point, we're going to go ahead and transition over to Mark Johnson. Mark is the sales leader for Southern US and Latin America with CalMac. As I mentioned, they are a portfolio of Ingersoll Rand and Trane Technologies, and Mark is kind enough to join us from his home in Florida. So Mark, please take it away.
Thank you very much. I appreciate it. It's good to be here. I'm going to talk a little bit about this same concept, but maybe broaden your perspective a little bit and start to talk about maybe the electric grid and the need for energy storage on the grid at building sites, particularly in the zero net energy site space. So it kind of all comes together. And so I just talk about a couple technologies here that are important in optimizing the building. So let's go to the next slide. So if you think about the utility grid, for years and years, this was really the model. You know, you had power plants that use a fossil fuel, that use nuclear energy. That's all stored energy, right? That's not something that's a renewable. You use energy as you need it to generate. And that energy flows one direction down to the end users. Let's go to the next slide. Kind of what's happening now, because of the zero net energy movement, because of the decarbonization movement, you're seeing much more remote inputs of energy into the grid. So if you drove across the United States, you see wind turbines all over the Midwest and out in California, out west. If you drive around North Carolina, I call it down east, you're going to see large PV farms. If you drive down into Florida, where I live, there are huge acres and acres of PV farms being built by the utilities. And so energy is being added to the grid from remote locations, and it's being added sporadically. You know, it's not like a power plant that can operate 24 hours a day and provide energy to a grid. It's renewable energy, so it really has no storage component. So as more and more of this sort of model develops with more and more zero net energy buildings, we just believe that you're going to see more and more need for storing energy, energy that you can store when you have excess production from wind or from solar, energy that you can store when you have excess production or availability from the electric utility, whether it's their nuke plants or their gas plants. So there's always going to be a need for energy storage, we believe, going forward as we go more and more towards this modern grid. Okay, next slide. So there's my little comparison. You know, you see fuel there on the left, that's stored energy. With wind and solar, we don't really have any storage component there. Let's go to the next slide. There are energy storage methods out there on the grid side of the meter. Pumped hydro. Many of you are from North Carolina, so I'm sure you've been up into the mountains. There are several pumped hydro lakes in the mountains of North Carolina owned by Duke Power. Also in Tennessee, TVA has a couple of these lakes where water is pumped into the upper reservoir at night using very cheap base-loaded energy and from the utility, and then a dam allows the water to release and go down to the lower reservoir, spinning a turbine to create energy. That technology's been around many years. There are other techniques, flywheels for short-term energy storage. You've all heard of Tesla and battery storage. That's on the right-hand side, upper right of this graphic. And there's also another method being looked at on the grid side, compressed air storage. This is similar to pumped hydro, where we're compressing air in caves underground using off-peak or very inexpensive electricity to compress that air and then releasing that energy during the day when we have peak periods and expensive power on the grid. So let's go to the next slide. If you want to go off grid, which is maybe the next step past zero net energy, you're going to have some storage, right? The sun doesn't shine 24 hours a day, the wind doesn't blow 24 hours a day. There will need to be storage, whether it's in your building mass for storage, whether it's in thermal storage for either heating. You probably all have a hot water heater in your home. That's a thermal storage system. It might be batteries. You may have to have a generator for those times when you don't have storage or you don't have any wind or solar. Let's go to the next slide. Of course, if you have the grid, then you may not need the storage because you can use the grid power as your backup capacity. But that in itself will cause challenges going forward. So ASHRAE recently did a study that said, well, if we're trying to go to net zero and we really want to get off of the grid, then you just have to have storage of some kind, and storage will help make this move much more possible and let it happen much quicker. Next slide. So here's I want to focus on this picture on the right. This is a energy storage system or thermal storage system for happens to be a community college, and it's to provide cooling. So you may recognize the chiller, the green box with the 6 fans on the top. That's a chiller that can produce cooling on demand when it needs to. That chiller can also produce cold solution that can freeze water that are inside those thermal storage vessels. And that particular plant right there has the ability to store around 720 kilowatt hours of storage, or 120 kilowatts of peak load in a building. So that's to kind of explain that a little better, that's the kW that would have been required if a chiller would have produced the cooling that's stored in those buildings. So you can imagine a building, we heard about some buildings that have maybe 50% net positive. Well, if you have a PV array that's not being fully utilized all the time, why not allow that PV array to produce power to operate this chiller in this photograph, to build storage, to build cooling for when you need it when the sun's not shining. So that's the idea with that plant there. Another way to operate that plant would be to use that chiller maybe when utility rates are much less expensive to help charge that. So there's an economic play. There's also zero net energy play with storage. And of course, batteries are out there on the building side. Tesla is really going great guns at that with that. And then there's also the ability to store energy in the form of water. So thermal energy storage tanks, that's the graphic in the middle, where we don't have the phase change of going to ice like we do on the graphic on the right. Okay, next slide. All right. I think we're all set. Just to summarize, you know, we're just one tool to use in a system that that can help optimize zero net energy buildings. I guess we'll turn it over now back to Rainer.
Okay, well, thank you so much, Mark. We appreciate all your technical knowledge on this topic. It's very helpful to see how storage comes into play as we're talking about using very little energy, generating a lot, and then needing to make sure that it gets to the right place. So thank you for that. So next up on our list is going to be Rainer Smith. Rainer is joining us from this side of the road. Thank you very much, Rainer. We know you've had a fun morning. And he will be talking about the design, build, automation, HVAC, artificial intelligence, just so much of this process. And he's a great resource for us to have. So Rainer, I'll turn it over to you.
Thanks, Ryan, and thanks, Barry, and thanks, Mark. I think this webinar is going to go down in the record book. So fortunately, we are an essential business, being a service and construction business, and most of our customers are too. So I was on my way to visit a project site. My car broke down. So while most of you are probably still in your pajamas and haven't brushed your hair yet, I'm on the side of the road on a park bench doing a webinar. So I don't know that we could have done this 5 years ago, probably certainly not 10 years ago, as we look at the technology that Zoom and Skype and GoTo have brought us. So this is pretty fun. So Building Clarity is an engineering, construction, and technology company. We focus on creating better lives for those impacted by the built environment. So what that means is focusing on systems, mechanical, HVAC systems, lighting systems, water systems, and improving those systems to provide better indoor air quality, to improve comfort, to improve uptime, to improve the efficiency of business operations. And certainly energy efficiency and the impact that we can have on the environment is part of the creating better lives. So what I'm going to talk about today kind of brings together what Barry and Mark were talking about around design, technology, and then how do you really make it all work? And then on top of that, how do you even afford to do it? I think we've all seen projects struggle to deploy high efficiency technologies or renewable energy sources. And there is a way, and you have to follow Barry's integrated project design, and you have to explore technologies like Mark, but there's also some economics at play too. So next slide. So Sandy Grove Middle School is a project that Barry talked about earlier. As that project came online around 2014, it was actually delivered through a contracting and finance method called public-private partnership, or P3 or PPP. And that just essentially means that a private entity is involved in somehow in financing, owning, and or operating the building. And in this case, Sandy Grove is owned and operated by a private entity called First Floor. And they also finance the project. It has recently turned back over to the school district after being in operation for a little over 5 years. But when this project first came online, when the students showed up in August, Barry's team and the development and operations team were seeing that the building wasn't performing as well as it could. It was performing well. It was net zero. It was producing more energy than it consumed on an annualized basis, but they knew it could be better. But their challenge was that they didn't have insights to the data. They couldn't see what was going on unless they were physically there, or unless the data was available through the building automation system. And up until 2014, that was really the only analytics technology that we had, at least in our industry. Now, advanced analytics and rule-based analytics has been around for a long time in other industries like healthcare and finance and supply chain, but our engineering and construction world seems to be a little bit behind in adopting, technology. So we got involved in the project to help the design team, the construction team, and the owner figure out how do we make this building better and help it operate more efficiently. So we plugged in an analytics platform. It was a rule-based system, and we began to expose data and patterns, anomalies that could improve operation. And over a couple of months, over the course of the winter and the early spring, we reduced the electrical demand by 40%, and we reduced energy consumption by 20%. And when I say we, it truly was a team effort. We were driving the technology, but the designers, the contractors, and the building operators were all involved in that process. Next slide. And by doing that and having constant visibility to the data, we were able to see pretty consistent operation. You can see this is the dashboard. It was actually in the lobby of the school and available online. And it has pretty consistent year-to-year operation from 2014 through 2017. You can see the green bars is the consumption at almost 750 to 770,000 kilowatt hours per year being produced by the solar system. And then the orange is the consumption, how much energy the building used. And it stayed pretty consistent in the mid 400,000s. You can also see that how much it reduced year over year from 540,000 down to 460,000 kilowatt hours. So a huge success. The building is still energy positive today, and the school district just absolutely loves the school. They use it as a teaching tool for the students and the teachers and the community. So it's been a great project. But what we realized with rule-based analytics is the analytics are really only as good as the rules that you write, and you cannot write human just can't write an infinite amount of rules and keep up with it. So we still had challenges where things wouldn't operate as they were expected. Maybe we had a bad month on the utility bill, and it was always kind of looking in hindsight. It was never real time, and that led us as we worked through 8 other net zero school projects. That led us to the latest school, next slide, which is Jones County School. Oh, sorry, we skipped, go back one, Ryan. We got to do the economics real quick. So before I go on the economics piece, so how do we pay for this, right? How do we pay for all this high performance technology? It certainly can be more expensive, but what we found by using the integrated design approach is the costs are actually roughly the same, maybe 5% more than a code compliant building. But there's really 3 parts to building and operating a school. Over the life cycle, there's 3 components. Are the first cost, what it actually costs to build the building, the interest expense. Most all buildings have some sort of debt. They're very rarely paid with cash, and even if it's paid with cash, there's a cost to that money. And then there's the operating expense. What does it take to maintain the building, and what does it take to pay the utility bill, the electrical bill, and the gas bill? And you can see on the left-hand side with traditional delivery, if Sandy Grove would have been delivered as we have normally done schools, a bond would have been placed. It would have had the first cost. The first cost would have been $21,500,000. The interest expense over the term of the debt would have been $16 million, and the electrical bill over the life cycle would have been $16 million. And that adds up to $53 million in total cost of ownership. That happened to be more than this school system could afford. And through the P3 delivery method and being net zero, at the top on the right, we were able to eliminate the utility bill. there's virtually no utility bill in this building. There may be some months, but it's usually less than $1,000. And so we eliminated $16 million of utility bills over the life of the building. Because it was financed by a private entity, they were able to get some interest-free financing through the federal government. So they had no interest expense on the building. And then there were other tax credits and earned interest that was delivered through the private entity that the public entity could not have taken advantage of. So the school actually cost the county $16.3 million over its life cycle versus $53.5 million if it were traditional delivery. So, net zero is possible. Energy positive is possible. You have to be creative. You have to be very purposeful and planful in the beginning. Make sure you have all the right partners on the team, from contractors to lenders to tax specialists. And it certainly can be done. If we go on to the next slide, Jones County was done the same way. It was a public-private partnership. Barry spoke about this one as well. A little bit of the same story, except for we knew what to expect going into the operations of the school. We also advanced from a rule-based analytics platform to an advanced analytics platform. So we have real-time data comparing the operation of the systems to the model, how they're supposed to operate, and alerting the building operators in real time when something goes out of whack. And in some cases can predict when things will fail, even though they may have not gone wrong yet. If we go on to the next slide, same story, a little bit more impressive story. You can see the traditional cost on the left at $101 million for the school. By eliminating the electrical bill, eliminating interest expense, and tax credits and grants, the school only cost the county $11.4 million over its life cycle. So just an amazing story. Not only that it's net zero, but this is a very poor county. They would have never been able to do this without this type of delivery and having a net zero school. So just it's been a great testament for the community. Next slide. Those are the solar panels on the roof. Many of you kind of know what that looks like, but nothing crazy there, right? It's solar panels on the roof. There's some maintenance, but we spent a lot of time understanding how the solar energy is going to be used compared to building operation. We're really applying pretty traditional technologies, but putting them all together in a way that might not normally be done. And that's it for my part. Back to you, Ryan.
All right, great. Thank you so much, Rainer, for that information. We appreciate your flexibility there. So, well, thankfully, we've got plenty of time for questions and answers. We've got about 12 more minutes for today's webinar, and we'll be happy to spend that time on audience questions. So for folks that are with us live, please go ahead and start putting your questions and comments into the Q&A feature here on Zoom, and we will begin taking those. While we're waiting for your questions, we've got a couple to kind of get us started. So I'm going to go back to our presenters and just have them answer one question at a time. And as questions come in from the Q&A, we will then address those in the middle. So first up, Barry and Mark, just to prompt you all, I think I'll start with you guys. First question is just going to be on the excess energy. So when we design these low energy buildings, we add renewables, we have storage. What happens with all of that excess energy? Where does it go and what do you do? So Barry, can you kick us off and then Mark fill in from there?
Right now we're working with each different utility depending on where the building is, and we're doing some kind of agreement to purchase energy that is not being used at that time. Not a great equation. We would like to get to the point of much more storage on site and eventually even get to the point of not being tied to the grid. But in the interim, we do buy all or sell all type of agreements. The downside really to that is that the negotiating leverage is clearly with the utility in the current state of things. So they're purchasing our energy at a much lower rate than they're selling us their energy. So it doesn't equate out to be a very positive situation.
Okay, thank you, Barry. Mark, do you have anything to add on that one?
Well, I mean, Barry alluded to it. When it's not a positive situation, and as technology in the storage realm gets more used to operating in this environment, becomes a little bit more cost effective, instead of selling back to the utility, I think we'll be putting that excess energy into storage devices, be it electrical batteries or thermal batteries. It's coming.
And Mark's absolutely right. It's really just it's a value equation right now. It's just getting the storage devices to be economical or cost competitive at this point to be able to use. We've been really fortunate with use of solar panels. We've seen a year-over-year decrease in the cost of solar panels. So it's become much easier to get those on buildings and get them to fit within the financial buildings. The same is true on the energy side. It's just not at the same pace yet. But as these technologies emerge and as they get used in a lot more, then that will definitely improve that situation.
Okay, great. Thank you so much for those responses. So we're going to turn over to the Q&A questions here. So we've got one question from Laurel. I'm not sure who would be best to answer this, so I'll take volunteers from our presenters here. But the question is, what are some specific challenges with Z&E and the mountains of North Carolina? So we do have different climate zones in North Carolina. We've got different markets, different economies, different utility rates, things like that. So Barry, Mark, or Rainer, do any of you all have specific comments on challenges that Z&E would encounter in the mountains?
This is Rainer. I'll take a stab at that one. So I think that it actually helps the situation. If you look at a lot of the net zero buildings that are out there, there are a lot on the West Coast, and in particular the Northwest, because they've got a very mild climate, at least annualized. They do have summers and they do have winters, but they certainly aren't as severe as the summers that we have here in the South. So as you move to the mountains, you're going to have a milder summer, and summers are more of a challenge for us on an energy efficiency and reducing consumption as much as possible. You also get the opportunity for some other technologies, whether it's geothermal, there may be some hydro opportunities. So I think the mountains, the only thing that might hurt you is on the solar side, but I think you could make up for any losses in solar efficiency with the improvements with the building efficiency.
Okay, great. Thank you, Rainer, for that answer. I think that was an excellent response. Appreciate that. So we've got two more questions. We'll go ahead and jump to these. The next one is from Marie. She asks, can any of the design companies speak about specific design aspects they use to make a building energy positive? So Barry, can you go ahead and touch on that one? So specific design aspects to go energy positive?
Yeah, I think the question might be coming from more of a building system standpoint, and Rainer can definitely jump in on this answer. But I'll add one other thing before I jump to building systems. We have learned that configuration, orientation of the building, I mean, we've known for a long time orientation is very important, but we have learned more over the iterations of the projects that we showed you that the compactness of the design actually has a pretty big impact on how to get there. And that's really related more to the conservation side. So, you know, the first piece of the puzzle is always try to get the building to use as little energy as possible so that you don't have to generate as much power on site. So it's kind of a simple equation that way. But as the project can get more compact or even multi-story, that really helps on the consumption side. You know, obviously multi-story starts to limit your roof space for solar panels. So it's just kind of a balancing act back and forth. On the building system side, and again, I'll probably defer mostly to Rainer, but I'll touch on the big ones for us. I know we look at lighting, so we're almost strictly LED lighting. There's really no reason to be even thinking anywhere beyond that. So we look at LED lighting for every fixture that is in the project, whether it's interior or exterior. We have some, we always look at a geothermal system. There are a lot more efficiencies coming back into some other systems, so that may be challenged in the near future. But over the last 5 years, geothermal has been a key component of everything that we've done. I've touched on dynamic glazing. That's a new technology, and I think that's going to play a big role. Just being able to control the solar heat gain coming through your windows is a big piece. Back on the architectural side, you know, the other is just the tightness of the envelope and the thermal performance of the envelope. So looking at what that window wall assembly is, looking at the ceiling, those are all important equations as well. And Rainer could go a lot more into all the other building systems that are coming into play.
Yeah, I think that in essence of time, well, I think Barry, you really hit it pretty good as far as systems. Again, we're constantly evaluating new building technologies, lighting and HVAC and building construction. I think the only thing to add to that is thinking about the data and how are you going to get the data out of whatever it may be, whether it's a light fixture, an HVAC system, a plumbing fixture, a solar panel, and so that you can ensure the systems are working as efficiently as they can together, not only individually but also together.
Okay, great. Well, thank you all for those responses. That's a good question. So we've got at least 3 more here in the list and a couple more minutes. So we'll see if we can jump through these quickly. So I'll ask the presenters to maybe chime in and we'll take these one at a time. So the question from Jennifer is about net zero energy and net zero carbon, understanding that they are different things. So who would like to just chime in on embodied carbon and how to create zero carbon buildings that take into account the carbon used and wasted in the construction and building processes? Do we have a volunteer for that one?
Rainer can maybe take a first stab at it. I love that question. It's the first time I've actually heard that question, but I mean, carbon is the new kilowatt hour, right? I think you look at the private sector and really even government too, and there is such a massive wave of how do we get to carbon neutral. Net zero is certainly part of that, but I think we're getting ready to see a major shift in the terminology we use and where we focus, and the effort that we put towards carbon reduction and GHG reduction. I heard the term carbon tech or climate tech rather yesterday instead of clean tech. Now we're talking about climate tech. And you look at Mark Johnson and he works for Train Technologies, and that is their mission, is to reduce the energy intensity of the world, as well as to attack and greenhouse gas emissions. So I don't know that there's a standard for it yet. It's a very insightful question, and I think in another year that's going to be pretty common language.
I'm just going to add a couple observations. You know, one of the key benefits of solar energy is that it's very clean. So that being a key component of just reaching net zero energy is helping us go in that direction by default. I do like the idea that there are there's great tools that are coming out now that give you a lot more knowledge based on the materials that you're putting into a building of what you're actually getting into. There's tools to help you look at the embodied carbon and try to set goals around carbon neutrality that are meaningful and tools in place to help you get there. There was also another product I just liked that we're using on the City Gateway project, which is actually sequestering or embedding carbon into the concrete mixture itself. It actually adds the benefit of increasing the strength of the concrete, but also takes some of that carbon and actually sequesters it. So there's a whole range of different ways to approach it. And I do think it, like Rainer has said, it's really the topic that is coming forward that really needs to be investigated in a much more thorough fashion as we move forward. Thank you.
I could add just one little quickie on this. and this is more about energy that we use for our buildings. You know, all the power plants out there in this country have their own ratings for the CO2e emissions that they're putting out, and they're different. So you can research that, and we're spending money doing that now, and looking at, you know, how does the CO2e emissions change by power plant, change as a function of the time of day. Think about California. In the middle of the day, 30% of their power is produced by PV. So there's not any, you know, there's zero CO2e there. But at night, it gets a little higher because we go to the fossil fuel based plants. So lots of research being done on that part of this equation now.
Great. Thank you, Mark, for chiming in on that one. We've obviously got a lot of input on that, and I agree that was a great question. So thank you, Jennifer, for that. So we've got 2 more questions, and we're pretty much at 11 o'clock, so I'm going to cap it there. And I would like to turn over to the next question. This one was on 3P, so Rainer and Barry, I think this one might kind of go back to you all, and we'll try to keep this short, of course. Do you think the interest costs will continue to be low for 3P or P3 delivery, or that eventually it will normalize to current interest rates for the standard delivery?
I can take a shot at that. I think the easy answer is yes. I don't think anybody really knows. I mean, the markets are a complete disaster right now, as you all probably know. The conversations that we're involved in with different lenders, the financial experts, is the summer and the fall will definitely be a good time to place debt. And it will be probably record low interest rates. Beyond that, I don't think anyone's really sure what's going to happen. But there will be other stimulus, there will be other grants, there will be tax incentives. So it's not just about interest expense. It's about pulling all the other things in the project to help finance it. But I think from what we're hearing, as soon as things kind of settle out this summer, once there's a vaccine, that we know that there's a vaccine on its way, the markets will settle, and it'll be a good time to finance projects, P3 and otherwise.
I'll just add one short one point. You know, with a P3, the beauty of a P3 arrangement is that you can look at financing from both sides, from the public sector as well as the private sector, and kind of look at the advantage, or where the advantage is, and where to pull those resources from. Oftentimes, the private sector has the ability to look at tax credits or other programs that can offset some of the interest rate expense. And that's what we've been able to do in the past. As interest rates continue to push lower as they are in the current market, it may be to a point where, you know, a municipal bond or some other financing tools may actually become more attractive than the private rate. So the beauty of the P3 is that it opens up the equation to both sides, and being able to just look at how to put your financial stack together in the most meaningful way for that project.
Great. Thank you both for those responses. So we've got one more question, and then we'll wrap up from there. Mark, I'd like to start with you on this last one. So the question came from one of our live attendees. Would it not be better for energy positive buildings to stay connected to the grid, which could include a community microgrid, in order to provide renewable energy access for homes of people who cannot afford to outfit their own homes with solar? That comment comes from an environmental and social equity purpose. We've obviously had a lot of conversation in all of our companies about making sure that all of these things are cost effective and some of the other benefits. So Mark, what do you think about making sure that these buildings stay connected for some of those environmental and social equity purposes?
I'd want to stay connected probably if it was my building, because it would mean I wouldn't have to invest as much money in trying to be not connected, right? I would have to invest less in storage, less in other technologies. And so I get that. You got to go also though look at what power are you using when you're connected to the grid? And are you trying to jump into this decarbonization and or not? Because most of the generation on the grid is, from fossil fuel plants still. It's changing slowly, but still most of it is fossil fuel related. So yeah, I mean, getting off the grid for buildings is that's a long-term proposition. That's not something that's going to be happening at a fast rate right now. So I don't see that. I see it as a nice goal, but nothing in the near future.
I think that's a really fantastic question, and a lot of the way we're going to be looking probably storage, energy storage on a building by building basis is not necessarily with the end goal of cutting the grid off and not being part of the grid. It's probably more so we can manage when we need to use grid power better. For instance, I don't know how familiar you are with the utilities, but they charge different rates at different times depending on the demand on their system. And so if you're able to control your own energy a little bit more effectively on site with storage, your first goal is really to make sure that you're only using energy from the grid when it's cheapest to you. And I think as storage becomes more prevalent and we have buildings that are more sophisticated, we'll put more pressure on policy around utility rates and eventually hopefully get to a better equation where the energy produced, the renewable energy that we're producing at a building level is able to be sold to the grid at a rate that is fair relative to the price that we're paying for that power when we need it.
Well said. Thank you, Mark and Barry. Okay, so that wraps up the questions that we had. So thanks everybody for asking those. We appreciate your feedback here live. Just as a matter of quick wrap up, a couple of resources. I do want to mention that NCBPA and a whole lot of our partners, including the Plumbing, Heating, and Cooling Contractors of North Carolina, are hosting a conference August 24 to 26 in Raleigh. Of course, we're watching the dates with the pandemic and travel restrictions, but it is scheduled. We have an entire track on zero net energy buildings that will feature an awful lot of content from the New Buildings Institute. So for folks that are interested in that first question on zero carbon, we've got that. All electric, we've got that. Financing, we've got that. Schools, much more. So each one of our speakers here today, I know will be joining us at our conference, wink, wink, as long as we're able to do it. So please pay attention to that conference. You can find more information at buildingprofessionals.net, and that's where the conference information is. Also, just one quote that I love to include in our presentations. This comes from Dylan, who is a construction superintendent for RE Design Build based here in Raleigh. That's a rendering of some passive houses that they've built here in the Raleigh area. Completely on the fly, doing a tour of those houses while they were mid-construction. Dylan offered this quote: we're never going to get to our carbon targets or energy targets just by ramping up our solar production. We need to be efficient and reduce first. $1 towards efficiency goes a lot farther than $1 towards production. That's what we do. You can find a 26-minute, very technical video on our website at buildingnc.org where Dylan gives us a tour of that project and describes how to do zero net energy. I want to say thanks to Rainer with Building Clarity, Mark with CalMac and Train Technologies, and Barry with SFLA for joining us today and offering all of their insight. This will be recorded, of course, and it will be sent out. So if you have any questions, feel free to get in contact with each one of our presenters and NCBPA as well. So thanks again to UNC Clean Tech for offering this webinar. We thank everybody for being with us today. And thank you very much to our presenters as well. And we hope everybody has a safe day. Stay safe, stay healthy, and take care out there, and get in touch if you have any questions on zero net energy buildings. And thanks very much.